different theories regarding the nature of light. So, in previous topics, we discussed Newton theory about the nature of light, Huygens wave theory about the light, and we discussed de Broglie dual nature of the light. These are the three topics we covered in last classes. So today we are going to discuss very important topics. So Maxwell electromagnetic theory about light. So he is the greatest scientist, James Clerk Maxwell. He proposed the theory how the light is propagating. So we will see this small visual graphic. We can analyze the what the Maxwell proposed the theory about the light. We can see this picture. We can get the clear idea on this. See, this the light is coming from the source. It is propagating from one point to another point. There is the light source is coming from one point to other point. Like this light is propagating. So you can easily observe here two types of transverse waves is appearing. So the Maxwell is proposed that the light is propagating as a waveform, as we see in the previous visual graphic. It will having two waveforms. One is the electric field wave, another one is the magnetic field wave. Those are fluctuating each other. They are fluctuating. So if you see previous one, the electric field will fluctuate to magnetic field. They are easily fluctuating to each other, So the electric field and magnetic field are consisting at right angle to each other. They will right angle to each other and also right angle to the propagation direction of the wave. So you can see once again, see here is the waveform. You can easily observe this one. B is the electric vector. Say if you see this one is the, if you see red color is having the magnetic field vector and black color is having the electric field vector, they are right angle to each other. Say this is having perpendicular to each other. They are two are having perpendicular to each other. They are propagating through this direction. So from source to another point. So they are perpendicular to each other as well as the perpendicular to the propagation direction. So the same thing the Maxwell tells that the wave will have propagating as a wave. The electric light will propagating in the waveform. So it is having electric field and magnetic field. It is having electric field and magnetic field, and also they are having the perpendicular to each other, and these two are perpendicular to each other as well as to the perpendicular to the propagation of the wave direction. See, with help of this proposal, with help of this theory, he successfully explained about the polarization of the light, property of the polarization of the light. I hope you are well familiar about the polarization of light. We will recall what is meant by polarization of light. Polarization of light is nothing but the light, the radiation of light, it will consisting of several orientation, the field vector having several direction, the orientation of the oscillation having the several directions. So these oscillations, if we confined to one plane, then the light is said to be polarized. That means the confining of vibration of the orientation of oscillations into one plane, on one plane, is nothing but polarization of light. So this is the one property of the light. You can easily understand with the help of this visualization. Say if you see this graphical visualization, you can easily understand. See, the light will, the source of light, natural light will having several orientation. I drawn only two type of orientation. So this is the one type of orientation fluctuation, this is the another type of orientation. In the same manner, you will having the light, normal light will having the all direction orientation, it will have confined, it will having the several direction orientation. For your understanding, I took only two direction orientation. So the light is passing through, it is incidenting on one material, after that it will reflect as well as it will transmit. If the material is the transparent material, it will transmit to through this one, some portion of the light will transmit to this one, and also some portion of the light will be reflected to the way. So according to the definition of the polarization, if these orientations, the vibration of the lights is confined to this single plane, then the light, that light will be called it as a polarization, polarized light. That process is named as the polarization. So if you see this one, when the light is coming, after incidenting to the light, see it will having single orientations. So this direction having a single orientation, this direction also having the single orientation. Then these two light reflected light as well as the transmitted light, you can call it as a polarized light. So you can easily understand, I hope. So the other theory, we are going to another theory, sun, that is the remaining the different theories in the light. Another one is the Max Planck quantum theory of light, Max Planck quantum theory of radiation. See, he is the greatest scientist, that the name is the Max Planck. So he proposed that the radiation, that means the absorbing or emitting radiation from any object or matter, must be in the form of electromagnetic radiation, and that smallest amount of radiation is named as the quanta or quantum. See, that means if any object that can be absorbed or emit that radiation only in the form of quanta or quantum. See, the radiation energy is directly proportional to the frequency of the radiation. So the energy of the radiation is directly proportional to the frequency of the radiation. That is, we can easily write the formula E is equal to h mu, where is the h is equal to Planck's constant. So he is given one of the definition, any object that can be absorbed or emission the energy between the any object that can be absorbed or emit the energy only in the discrete manner of energy. Discrete manner, that means it may not having the continuous energy pattern, it is like discrete manner, that is equal to the energy may be 0 or 1 h mu or 2 h mu or n h mu. So this definition is called as a quantization of energy. What is meaning of quantization of energy? I hope you understand. That means the absorption of the energy or emitting of the emission energy from any object, it will be having only in the discrete manner, not in the continuous manner. That is named as the quantization of energy. So this is the quantum, Max Planck's quantum is given about the light, the theory about the light. One is the object will radiate or emit the radiation only in the form of small amount of radiation. That amount named is the quanta or quantization. So the energy is directly proportional to the frequency of the radiation. That energy will having only in the discrete manner, the exchange of energy in the form of discrete manner. So that is named as the quantization of energy. See, after the Planck's theory, Einstein came to the picture. He used that one. He determined that the light will present in the discrete quantization quantum energy. It is named as the energy packets. So it is given in the name of the energy packets. These energy packets are named as the photon. So the energy packet which we used in the previous one, quanta, that energy, the quanta only given name by the photon by the scientist of Einstein. So with help of these assumptions, Einstein is able to give the clear picture, clear explanation about the photoelectric effect. So I hope you already familiar about the what is mean by photoelectric effect. I already discussed in your previous class and previous video also. So the photoelectric effect is nothing but if the suitable incident of the radiation is incidenting on the suitable such material, so then they can release the electrons. So that means if the suitable radiation is incident certain type of metals, they can release the electron. If this material is connected to the one loop, so the loop can be give the electricity. So this is the photoelectric effect. So with help of these two phenomena, one is the Max Planck quantum theory, and we will give to the another one. We taken two theories. One is the Max Planck's quantum theory, another one is the we are taking that electromagnetic theory, Maxwell electromagnetic theory. This with help of these two theory, one he will given clearly picture about the polarization phenomena of the radiation. He given the clear picture about the polarization. So another one with help of the Einstein photon theory, he can photon explanation. So he can able to explain the photoelectric effect. So the property of the lights, all properties are successfully explained with these theories. So the all properties are successfully explained with the help of these theories. Thank you for watching.